Alright, dear children of class 12 science, so let me just continue with the topic which I was explaining in the last YouTube video, but it was incomplete. Actually, I was explaining that when we change the potential difference across the end of this plate, two plates, by keeping this, inserting two plugs at two of the commutator, P1 become negative plate, P1 become positive plate, and P2 become negative plate. So when P2 become negative plate, and when we increase this potential, the potential of P2 with respect to P1, okay, then we see that there is a decrease of what? Current. The photoelectric current flows to the circuit, and that current even becomes zero at certain potential. But children, which is the device that can change the potential at P2 with respect to P1? This device. This is called potential divider. This potential divider can vary the potential between the two plates of this evacuated glass tube. But as I said, when this potential increases, okay, when this potential increases, positive potential increases with respect to P1, then current decreases more rapidly. But at a certain potential of P2 with respect to P1, the current will become zero. Now, why current becomes zero means because, as I said already in the last YouTube video also, that whatever electrons will emit from this plate P1, they move with different kinetic energy. Some electron move with more kinetic energy, some electron move with less kinetic energy. But in order to stop all the photoelectrons, which are moving from P1 to P2, we have to apply that potential of P2 with respect to P1, so that all the photoelectron will not move from P1 to P2. That means they all completely stop the motion of all the photoelectrons. And motion of photoelectron stop means current will also not flow. No flow of current takes place, because current is the rate of flow of electrons. And what electron? Photoelectrons. So there must be a potential, positive potential of P2. Okay, sorry, negative potential. This is negative potential. This is positive potential. So negative potential of P2 with respect to P1, so that the photoelectric current becomes zero. So that all the photoelectron emitted from P1 get stopped. And that negative potential of P2 with respect to P1 is actually called as cutoff potential. So children, try to understand what potential? Cutoff potential, or also known as stopping potential. So what is stopping potential? This type of question will ask. Stopping potential or cutoff potential is the negative potential of P2 with respect to P1, so that the current, the photoelectric current become what? Zero. And that potential is called stopping potential and cutoff potential. So from here we can say that the potential difference between the two plates can change the current. That means there is an effect of what? Potential difference on photoelectric current. Now children, whatever experimental observation we discussed just now, that experimental observation can be expressed in the form of graph. Means this graph is very important, and from this graph we can even express a potential called stopping potential or cutoff potential. So the graph that we are going to plot is a graph between current and potential difference. Current and what? Potential difference. That means the effect of potential difference on photoelectric current. Now, the graph also in two parts. One is for positive potential, one is for negative potential. So this axis is positive axis, this axis is negative axis. This is the x-axis, and this is y-axis. So y-axis we are taking as current, and x-axis we are taking as potential difference. Now you know, when P1 is negative potential and P2 is positive potential, that you have learned already, that time there is a maximum current flows through the circuit, and that current is called photoelectric current. So when P2 is positive potential and P1 is negative potential, then there is a maximum current and constant current flows through the circuit. And this constant current is for a certain intensity of light, because you learn already that intensity changes the current. And this is the graph that you learn, that intensity increases, current also increases. But the graph which I have drawn, this is a straight line graph parallel to this axis, say that the current flowing at a given intensity of light is constant when P1 is negative and P2 is positive. Okay, but when the intensity is doubled, the current also become what? Doubled. But at that intensity of light, so I become 2I, the current it also become doubled. But that current also become a maximum and become doubled. So remember children, this is the graph which I plot when P1 is negative, P2 is positive. P2 is what? Positive. Okay. So in that case, at a given intensity of light, the current flowing in the circuit of given intensity of light remain constant. But when the intensity is doubled, current also become doubled. But the next part of the graph that we are going to plot is when P1 is positive plate and P2 is negative plate. Which P1 is this side positive plate, P2 is negative plate. So when the polarity changes, then when you increase the negative potential of P2, the current start decreasing. It decreases this way. It decreases, keep on decreasing. But at a certain potential, negative potential of P2, this current becomes 0. And that particular potential is given by B naught. So I am expressed by B naught. And this B naught is called stopping, or also called what potential? Cutoff potential. Stopping also called what potential? Cutoff potential. So children, stopping potential or cutoff potential is the negative potential of P2 with respect to P1. So that at this potential, the photoelectric current becomes 0. See, it becomes 0. But this stopping potential is independent of the current. The amount of current and the intensity in which the light is incident on the plate. So even at this intensity of light, when you increase the stopping potential, the current also becomes 0 at the same stopping potential. See, becomes 0 at the same stopping potential. That means this is that negative potential where the photoelectric current becomes 0. So that means there is no flow of photoelectrons from one plate to another plate. But this stopping potential is completely independent of the intensity of what? Light. And children, for information, stopping potential we mark by letter B naught, or we can also mark by letter BS. In some book you find using the symbol of stopping potential as BS also, or you can use B naught. So we use out here B naught. But as I said already that it is the negative retarding potential. It is the negative potential also called the retarding potential at which the photoelectric current becomes 0. Okay, photoelectric current becomes 0. And this stopping potential is completely, we have measured on given frequency of light. Given frequency of light. Because stopping potential depends on the frequency of light that you learn afterwards. But stopping potential is completely independent on the intensity of light. Even if the intensity is doubled, okay, the stopping potential will measure same. Now children, we go to the next part of this stopping potential that is very important, and this is actually what means when you reach to stopping potential, that stopping potential stops the flow of electrons which are moving with maximum kinetic energy. Which are moving with what? Maximum kinetic energy. That's why stopping potential can also be expressed in terms of maximum kinetic energy of photoelectrons. And maximum kinetic energy of photoelectrons is marked by letter EK. So I'm marking EK is the maximum kinetic energy of photoelectrons, and you know kinetic energy is given by half m b max square. Means when kinetic energy become maximum, when velocity become maximum. Because every photoelectron has mass also. So the maximum kinetic energy of photoelectron is given by half m b max square. But this maximum kinetic energy of photoelectron is exactly equals to E into B naught. That's why stopping potential is expressed in terms of maximum kinetic energy by this relation. So look at the relation. E B naught equals to half m B max square. So when we measure stopping potential, we can measure by this relation also. Where E, children, you can see E is the charge of electron, the charge of photoelectrons. So children, one conclusion I can draw from this particular part that you need to understand is that at stopping potential, the photoelectric current cannot be obtained. When you apply stopping potential, the photoelectric current cannot obtain from the plates, which means the maximum what? The maximum what? Kinetic energy of photoelectron. That means maximum kinetic photoelectron means the stopping potential is independent on the intensity of light. That's why already I said stopping potential or maximum kinetic of photoelectrons is independent on the intensity of light. But it depends on the frequency of light. Because frequency changes, kinetic energy also changes. And that you learn in the next YouTube video also. But as I said that stopping potential or maximum kinetic energy of photoelectron is completely independent on the intensity of light. So children, I have explained a very important graph as for the topic photoelectric effect is concerned. Now we go to the next topic from the experimental observation, that is the effect of frequency of incident radiation on stopping potential. So stopping potential will be changed if the frequency of incident light changes. Means frequency changes the maximum kinetic energy of photoelectrons. When kinetic energy of photoelectron increases, by increasing the frequency, you have to increase the stopping potential also, which means we can now go to the next part, that is the frequency of incident light also affect the what? Depends on the stopping potential. And children, the dependence of frequency of incident light on the stopping potential and the other topic which are also there, that you learn in the next YouTube video.